Hi, AB Calculus. We're on 2006, question number 5. And right now we are doing part A. Now, I'm not trying to scare you, I want to make you realistic. Your AP exam is made up of 3 free response questions. I'll get more information, but as of right now, I'm just assuming they're like free response questions out of the booklet. And they've gotten rid of some topics. This topic they have not gotten rid of. This is one of the topics. I think this could be like one of the questions on your AP exam. Like 1/3 of the points. If there's only 3 free response questions, 1/3 of the points from one of the questions. And hey, here you go. So it's an easy question. We should do great on it, but it might be a little sneaky. So let's make sure we understand what's going on and get the points that we can get. So the first thing we need is a slope field. And you'll notice here, for part A, I'm going to plug in these 8 ordered pairs into this and get slopes. So it's 1 plus y over x. Okay, so 1 plus my y is a 0, my x is a 2. My y is a 1, my x is a 1, my y is a 0, my x is a 1, my y is a -1, my x is a 1. So here I get a slope of 1/2, and 2, and 1, and 0. Alright, so at 2, 0, I have a slope of 1/2. At 1, 1, I have a slope of 2. At 1, 0, I have a slope of 1. And at 1, -1, I have a slope of 0. If we continue on the other side, 1 plus y over x, 1 plus y over x, 1 plus y over x, 1 plus y over x. Here we get a slope of -1/2, -2, -1, and 0. So a slope of -1/2, -2, -1, 0. And there you go. This whole thing's worth 2 points. Remember, if it's 3 free response questions, each worth 9 points, there's 27 points you can earn on the AP exam. And I would bet you can pass this year with only 1/3 of the points. 9 out of 27. Now that means you destroy one of the free response questions. You get 9 out of 9. You've already passed the AP exam. Assuming we know what the questions are going to look like, which we don't, but when I get more information, I'll make sure you know. Alright, so that's part A, and now we're going to go ahead and look at part B. So part B says solve the particular differential equation. Solve or find the particular solution to the differential equation. This is separate and integrate. You need to underline solve the particular differential equation. Make sure you understand that separate and integrate. And to do separate and integrate, first of all, the dx has to multiply to the other side. So here the dx is. The x is on the bottom, it has to stay there. And the dy is over here. dy stays here, and dx immediately goes to the other side. Now, this piece right here has to go to the other side. If it's attached by a plus or minus, it has to go with it. It's on here on the top, so we have to multiply by its reciprocal or divide it to the other side. We need a placeholder up here. There's a 1. So that's separated. If it's on the top, once it gets to the other side, it's on the bottom. And again, the x is on the bottom. It doesn't go anywhere. It has to stay there. Now, when I go to take the antiderivative, there's something I want you to notice, which I'm sure you already have noticed. Bottom exponent's 1 bigger than the top. These are both perfectly du over u's. Remember, if it's du over u, absolute value of u, ln u plus c. So look at this one. For the first one, if my u is 1 plus y, my du is 1 dy. And what do we have on top? 1 dy. So this is already du over u. So it's ln of u. And over here, I mean, if x is on the bottom, the du is 1 dx. Perfect. This is exactly du over u. So this is ln of x plus c. Now, we want to earn as many points as possible. I'm going to do something that probably is not going to be as pretty, and we're not going to get all 9 out of 9 points, maybe, but I want to get as many points as possible. So, I separate, I integrate, I have now earned like 4 out of the 7 points, or 3 out of the 7 points. As soon as I possibly can, I put plus C and I plug in to solve for C. Now, notice in this problem they say the initial condition is -1, 1. Or f of -1 is 1. So that's the x, that's the y. So the y is 1, the x is a -1. So over here we get ln of 2. And I want you to notice here, does this absolute value on this side have a job? No. Does not have a job. That's going to be important later on. And on the other side, absolute value does have a job, and the ln of -1 is 1. And if we want to know what is ln of 1, remember ln of 1 is 0, ln of b is 1. You've got to know these two ideas. So ln of 1 is 0. So we get 0 plus c. In other words, c is ln of 2. And if c is ln of 2, it's got to get plugged back in. All right, so we're going to plug it back in. I'm going to be off the screen a little bit. I apologize. So here we have ln of 1 plus y equals ln of x plus c, which is ln of 2. Now, I just want the points. So to get the points, I'm going to go as quickly as possible. Now, I'm going to show you a nicer way we could have finished the problem. But, hey, let's get the points. We e both sides. This e does not destroy this ln because of the plus sign. Okay? And now here's where we run into something important. These absolute values. Did those absolute values ever have a job? No. So these absolute values can go away, and I can get y by itself by simply subtracting the 1 to the other side. Minus 1. It's ugly, but that's all the points. Now, the question is, what is the domain? So we're going to talk about that really quickly, just so you know, and I'll show it to you 2 different ways later on. But the domain, the final point, is simply the x's have to be less than 0. What do I mean? Remember ln of x? Do you see? Remember x way back here, the absolute value had a job? So in this problem, its job is basically to take negative things and make them positive. That's the job. The job of the absolute value, it had a job. If it has a job, it meant because we have negative numbers in here. So if we're going to have negative numbers in here, x less than 0 is the domain. Now, I want to show this to you a different way, which will be more obvious if we clean things up. So there are several different ways of solving for C. But one of the different ways is right here to break this up. E to the this times e to the this. So again, over here we have 1 plus y, and on the other side we can break this up. E to the ln of x times, it becomes multiplication, e to the ln 2. And both of these get destroyed. And if they get destroyed, we're now left with the absolute value of x times 2, or 2 absolute values of x. And then the plus 1 subtracts to the other side. Now, these are actually the same equation. They just don't look the same. But what I want to point out, you guys know what an absolute value graph looks like. That's the absolute value of x. If you put a 2 in front, the 2 in front makes it steeper. You put the minus 1, it shifts it down 1. So if you look back over here to this graph, basically what we found was this line. But there's a problem. On slope fields, you can never pass an undefined slope. Now, mainly on slope fields, we've seen that as lines like this, where they go whoop, and then you can't pass an undefined slope on a slope field because it's a vertical line. But absolute values have a sharp turn. Sharp turns are also undefined. So in this problem, because we started on this side at -1, 1, we run into an undefined slope, a sharp turn, and the graph stops here. And that's another way of thinking about why the x's had to be less than 0. Anyways, pretty easy question for most of the points. The only point that was a little bit difficult at the end was to get the domain, and I hope that went well for you.